In this video, we are going to learn about the construction and working of depletion type MOSFET. The full form of MOSFET is metal oxide semiconductor field effect transistor, which is a type of field effect transistor which controls the flow of current in a circuit using electric field. There are two main types of MOSFETs, enhancement type MOSFET and depletion type MOSFET. Our focus today is on depletion type MOSFET, which comes in two versions. First is N-channel depletion type MOSFET and second is P-channel depletion type MOSFET. We will first discuss the construction of both the types, then move on to the working of each type. Now let's talk about how the depletion type MOSFET is constructed. To make it easy to understand, let's break it down into three main parts. First is substrate. Substrate is the base material where the MOSFET is built. It is made of either P-type or N-type semiconductor material. In N-channel depletion type MOSFET, the substrate is made of P-type semiconductor material, where in P-channel depletion type MOSFET, the substrate is made of N-type semiconductor material. In P-type material, the majority of charge carriers are holes, and in N-type material, the majority of charge carriers are electrons. Next is source and drain. The source is where the electrons enters the MOSFET, and the drain is where the electrons exit the MOSFET. In N-channel depletion type MOSFET, the channel is made of N-type material formed between source and drain. The source and drain terminals are heavily doped with N+ regions. Wherein P-channel depletion type MOSFET, the channel is made of P-type material between the source and drain. The source and drain terminals are heavily doped with P+ regions. Third is gate and insulator. Between the source and drain, there is a thin layer of insulating material called silicon dioxide. On top of this insulating layer, there is a metal contact called the gate. The gate terminal is where we apply voltage to control the flow of current between the source and drain. Now that we have covered the construction of both N-channel and P-channel depletion type MOSFET, let's move on to how each type works. The working principle of both N-channel and P-channel MOSFETs is similar, but it involves opposite polarity of voltage. In N-channel depletion type MOSFET, the flow of current is due to electrons since it is N-type semiconductor. During the working of N-channel depletion type MOSFET, when no voltage is applied to the gate, the channel of electrons already exists between the source and drain. As a result, current can flow between the source and drain when no voltage is applied between them. This is the default state, and the MOSFET is normally on, allowing current to flow. When a negative voltage is applied to the gate voltage repels the electrons in N-channel, reducing the number of electrons available for conduction. This process is called depletion. It decreases the current flow between the source and drain. If the negative voltage is strong enough, it can stop current flow entirely. When a positive voltage is applied to the gate, the positive voltage increases the number of electrons in N-channel, allowing even more current to flow between the source and drain. This enhances the conduction. In P-channel depletion type MOSFET, the flow of current is due to holes, since it is P-type semiconductor. During the working of P-channel depletion type MOSFET, when no voltage is applied to the gate, a natural channel of hole exists, allowing current to flow between the source and drain when voltage is applied. This is default on state. When positive voltage is applied to the gate voltage repels the holes in P-channel, depleting the channel of charge carriers. This reduces the current flow between the source and drain. When negative voltage is applied to the gate, a negative gate voltage increases the number of holes in P-channel, allowing more current to flow between the source and drain. This enhances the conduction. Now that we have understand the construction and working of depletion type MOSFETs, let's look at some of its applications. First is analog switches. These MOSFETs can be used as a switches in circuits. In their default state, without gate voltage, they conduct electricity. When voltage is applied to the gate, they can be switched off. Next is amplifiers. Depletion type MOSFETs are used in signal amplification. They can amplify weak electric signals in devices like radios, televisions, and audio equipment. Next is voltage regulators. They are used in voltage regulation circuits to maintain a stable output voltage, especially in power supply circuits for electronic devices. Next is protection circuits. These MOSFETs are used in circuits that need to protect sensitive components from excessive current. They are commonly used in overvoltage protection circuits to block high current when needed. Next is oscillators. Depletion type MOSFETs are used to generate stable frequency in oscillators. This is very useful in communication systems where accurate timing is essential. Next is current regulators. Since depletion type MOSFETs can control current flow, they are used in circuits where it is necessary to maintain constant current, such as in power supplies and battery chargers.